Hi, my name is C.Vantrease, and today I'm going to show you how to machine your StepBar. Step 1, you're going to get your StepBar process plan, and the first part on that is you're going to obtain your print. Then you're going to calculate your speeds and feeds for the specific diameters. So there's 6 diameters on here. Each one will need its own speeds and feeds. So our formula is cutting speed times 4 divided by diameter. For this, I'm going to use the cutting speed of 200. So 200 times 4 divided by diameter. All of our cutting speed is going to be 800 divided by whatever diameter we're working on. So diameter 1 is 1.25. So we have our calculator here. So 800 divided by 1.25, 640 RPM, revolutions per minute. And we're just going to go down the line and do that for every measurement. So that is all the RPMs you'll need to turn this part. Your feed rate, a roughing feed rate, is going to be roughly 12 thou per revolution. Or IPR. So now that we have our RPMs that we want to machine at, we need to select them on the machine. So our starting RPM is 640 RPM. If we come down the line here, we have from 32 to 1800, but there is no 640 exactly. So we need to pick high or low to split the difference between what we have here. We have 510 or 710. I'm going to pick 710 because carbide versus steel, it can handle a little bit of extra. So if we look at the handle positions, we need to go into the high range, and we need to have this one all the way in and this one all the way out. If the machine does not go into gear smoothly, so for whatever reason it won't go into gear, rotate the chuck by hand as you try to push the lever into gear. Now for your speeds and feeds. So for our initial roughing, I want to use 12 thousandths per revolution. So we will come to our chart here. We want our longitudinal feed, and we will find 12 thou. So that is ACG in tumbler position 1. So we will move A. C is off here, and C should always be in the correct place, but double check it. And then here's your G or F selection. So all the way this way is G, and we need, yep, ACG. So ACG, and then we need tumbler position 1. So we will pull the handle out and rotate it down and out of the way, and then put it into position 1. Now that we have 1 and 2 complete, now we need to gather the appropriate tools. So I'm going to use a 0 to 6 inch caliper. Our material is 1.5 inches by 8 inches long, and for our machining tools, all we will need for this next part is a standard turning tool. So that is your standard turning tool. Inspect the tip and make sure it is in good condition. And we will need a center drill. I believe this is a number 3. We need to install our material. So I will take my chuck wrench, open the jaws. I want to leave the material roughly 1 inch out, so about 1 finger knuckle out, and tighten the jaws. Now we need to install our turning tool. So I will open the wedge all the way, clean the top of the post off, make sure our dovetails are clean, laying the tool in here, and lock our dovetail. And as for installing our tailstock, there's a key in the back of the tailstock. You will insert it slowly. First, make sure all your surfaces are clean. Insert it slowly. You will feel it engage those teeth. And then pull it out slightly and send it home. That is the full position. To remove tailstocks, we simply retract the quill all the way and it will pop the tool out. Now that we have our tools in here, we need to make our facing cuts. I have the lathe set at 1,000 RPM, and we're going to just do this all by hand. Notice that the tool is not cutting on center. It's leaving a large section in the middle that is not being cut. So we need to loosen our tool post and raise the tool onto the center line of our machine. And now we can try to cut it. This may take several small adjustments. Now that there's no stud left in the middle, it is one smooth surface, we will remove the tool entirely. We will bring our center drill up. And we will put a center drill on our part. And that is plenty there. We did not get into the body of this center drill. We left that cone shape from the center section onto our part. Now that we have center drilled our part, we need to extend it out and engage it with our live center. So a live center is one that has bearings in it. Loosen the chuck. We need to have it slightly longer than 6 inches sticking out because 6 inches is our finished part length. So I'm going to bring it out, maybe an inch longer than our calipers can measure. Now we need to bring our center over. So first I'm going to bring my tool to the start of the cut so I don't accidentally run out of room. Extend the quill of our livestock out, or tailstock out. So the way we can tell that our center is tight enough is we're going to push out on the quill until I can no longer spin the center without moving the entire chuck. That way it actually stabilizes through the entire tailstock of this machine. This locks the tailstock in place. This handle here locks the quill in place. Now that we've done 8 and 9, we need to do 10 and 11. I'll show you how to use the DRO real quick, and then I'll show you how to touch off your tool. So if I move to any position, so right now I'm moving longitudinally, which is my Z on this machine. So if I need to zero it at any given point, I can just click this yellow arrow and it will zero it out. Same with X. If for whatever reason I needed to enter in a number, I can call up preset. I can select my axis that I want to preset, and then I can type in whatever number I want and then hit enter. But for what we're doing today, we are only going to be using this button here. Now for actually setting our tools, we will come first to the face. So we will wiggle our tool down into between our face of our part, this section we just machined earlier, and our center. And we want to go roughly a third down the insert. I'm going to kick the lathe over into my first cutting RPM. So in this case, 710. Now when I turn it on, I'm going to slowly move in the Z direction, which is the big hand wheel, until I just touch my part. See how I just made a chip? Now I'm going to come up to our DRO and Z face measure, because that is the Z direction. Click this yellow arrow and it will zero it out. For getting X diameter, I'm going to come over somewhere a third down the shaft, maybe a 1/4 inch down. I'm going to touch it, come off the edge. I'm going to dial in roughly 20 thou for this part, because I know we have a lot of material to remove. I'm going to engage the feed rate. I'm going to kill it, come back to the start. Same with X. Now I'm going to take my calipers and get my measurement. That's all you need to turn for your initial touch off, is just enough to get a measuring tool in there so you can know where you're at. So I'm getting 1 inch, 400, it looks like 78, 79. So I'm going to write that down. My initial test cut was 1 inch, 478. That's the diameter that that tool, is set at currently. My target diameter is 1 inch, 250. So subtract those two will be the amount you need to actually machine. So I have 228 thousandths, because remember, hundredths, tenths, thousandths. So 228 thou to go before this part is at my first diameter. So for my first cut, first I'm going to make sure that I can go the full length of my part, which is 6 inches in this case. So I have plenty of room. Now what we need to do is dial in a appropriate amount of cut. So y'all being students, this machine can take quite the cut, but y'all ain't there yet. So we're going to limit our cuts to roughly 50 thou. On the DRO, we're going to go in positive 50. We are going to power feed past 6 inches on this part, because this extra material over here is nothing but scrap. I am not going to lift the tool just because it's easier, especially for you guys. Something was making some noise, so let's check that. My center has came loose for whatever reason. So I'm gonna unlock the quill, push a little bit, lock it back in. Now we're back in business. And remember, we had 228 to go. So we just took 50. So let's take a couple more passes. And notice how the chips are coming off this tool manageable. If your chips are coming off too long and stringy, that's dangerous because it's a cutting hazard. And you can either play with your depth of cut, play with your speeds and feeds, but it should be able to make nice chips like this. Cut here puts me at 200 thousandths smaller than the original part. So I'm going, after this cut, I will stop, measure the part, and make sure that the numbers that the DRO is showing us make sense with what's actually happening on the material. See, those are the kind of chips we're talking about that can be potentially dangerous. But considering this is a finished pass, I'm not going to worry about it too much because we aren't making a lot of them. Notice how there's not as many swirls when we go back to the other side, because we took all that tool pressure from our roughing passes and just about eliminated it from our light slow feed finishing pass. Now that we've done our finishing pass, we need to measure a part, and specifically we want to measure where it matters on our part, which is this last section down here. So we measure right here. I'm at 1 inch 263, so I've got 13 thou to go. And because this machine took that 15,000th pass relatively accurately, I believe that if I take the 13th thou pass, I will land within spec, and that also aligns roughly with our tip diameter on our minimum depth of cut on our insert. Now, in theory, this diameter should line up with our print callout. We should be there. So, what you may or may not be able to see right there, we are at exactly, well, exactly, we're at 1 inch, 249. So, I'm a thou under, I'll live with that. So, the lathe is set up for roughing. Our next step, each one of these is 1 inch long. So, from the end of this shelf to the start of this one should be 5 inches. So we're going to turn back a 5-inch length. Now our Z is very important for our project. So I'm going to turn it back 4-inch 900 and then hand feed it to roughly 5-inch. Found depth of cut, engaging our feed. So I'm going to stop a little bit before, and I'm going to go to about 980 thou. And then I'll leave the last 20 or so for our finished pass. I got ahead of myself. We only need to go 100 thou. So yeah. Whoops. Good thing this part has a bunch of steps on it. So now, let's go back to our 100. And we'll do the same thing. We had 24 thou to go. So we will go in 12 thou. We will turn to a finishing feed rate. Generally, we want to go half our depth of cut on our finish passes. So if I have 24 to go, I'm going to go 12. And then if it didn't line up with my measurements, I'll go 6, and so on and so forth until I hit my desired dimension. Measure our part. So our measurements didn't line up, and I have 9 thousandths of material left on our part. So I'm going to go 0, half of 9 is like 4.5. So I'm going to go 5 thou. And notice if I miss my number, I have to come back quite a bit, and then I can go back to my number. So let's go 5. 5.2, that's good enough. Another finish pass. Yeah, the DRO is not working with us here very nicely, because that cut there took us to 1 thou over our dimension. We were supposed to be 1.8", and we are now at 126 thou. So that's why if our initial numbers don't work out, we go half the expected amount. So now I'm still have to get to my 5-inch, so I'm actually going to rerun that same pass, which will shrink me about 1 thou, and go to our full 5-inch. So now I'm going to go to my full final depth, and I'm just kind of barely tapping it in. So there's my final depth. I'm going to push the power feed handle out and down, which is going to power feed out for it. And that just made a nice, perfectly square shoulder. Now that you have the general premise for how to do this, let's just roll through these next couple steps. And because we are going, well, now we're at 800 theoretical RPM, I will leave my machine set up, but on the next step we'll go up to 1010. because that chip was getting a little bit out of control, let's try to change up our feeds and speeds a little bit to make that go away. That wasn't quite the answer either. So let's try to go the other way. More manageable chip is what we're after. Now I tried increasing my feed rate and I just made a more gnarly chip. Decreasing it just a little bit seems to make it curl over on itself and break. Finishing feed rate. Go in 12 thou. Measure. So I've got 2 thou to go. Technically I'm in spec, but I'll take a thou. First hand feed to the full length, 1 inch. Pull it off this way to get a nice sharp shoulder. So now at this point all of our diameters are to spec. Now we need to double check our lengths, and we'll do that while it's in the machine so we can still fix some things if it's wrong. So to double check the lengths, I'm either going to use the tail of my, and make sure you're not on the radius left by the tool nose. go all the way in. So I'm at exactly 1 inch. Now that doesn't really work because my starts getting in the way of itself. So I think I'm 1 inch, but we can also use from here to here. That is also an accurate step. So this one I'm actually getting roughly. Okay, so that checks out good enough for this project. Now I need to deburr all these sharp edges with a file. So I have my file heel, only use ones with a handle. My machine is set at 1,000 RPM. Left hand on the handle, right hand in front, and I'm just going to give them a little kiss. Just to break that burr. Just like that. Now that we have our steps complete, we just need to cut off the excess. And remember, we left this section at 1 inch 300 and a bit. So I'm just going to simply put this in the saw. Now we can put this in the scrap pile. And this is ready to finish this in. Now that we're almost done, I need to face this step here to length. So I need to make sure that I have access to measure, and so I'm going to hold it by this step here, but not quite up against that shoulder. So you can see here, I still have room to get in here and measure. And you can see I have, my goal is 1 inch. I have 300 thou to go. Stop it to check our progress. Our tool is still on center height. So I have about 133 to go. Even though I have a lot of material to face off, you don't want to take heavy facing cuts with a tool in this orientation. If you want to take heavy facing cuts, you need to get a different oriented tool, one designed for that. This one is not designed for heavy facing cuts. So that's 112 thou off my DRO. I'm going to re-zero it, check, and on this last pass, I'm actually going to use power feed to finish. So I've got 20 to go. So I'll take 10, measure, and then take the other 10. And this is under power feed. Go back to where I was. And measure. So I have exactly 10 thou to go. So I'll go in that last 10 thou. And that is how you machine a StepBar from start to finish. Start to finish, this jaw will leave a mark. If you want to avoid that, you can use some aluminum shims cut from a pop can to just protect your surface here.